Good evening, everyone. My name is Veerbhadra Patil. I'm from Skillemme. Thank you for registering for this session. We are excited to have Mr. Amarjeet as a facilitator for today's session on introduction to microservices and core design patterns. Mr. Amarjeet brings deep expertise in software architecture, enterprise application development, and modern engineering practices. With hands-on experience in designing and implementing microservices at scale, his sessions are known for blending clarity, practical insights, and real-world applications. We hope you make the best use of this session. It promises to be very insightful and packed with key takeaways you can apply in your real-world projects. So wishing you an engaging and productive learning experience. So over to you, Mr. Amarjeet.
Thanks, and hello everyone, and very good evening to all of you. And thank you very much for joining this session where we're talking about microservice architecture and the basic principle. So before we proceed ahead, let me try to give you a quick brief about myself. Friends, my name is Amarjeet, and working as a senior consultant and a technical architect with close to around 21 years of experience. And in last 21 years, I have given my services to more than, I can say, 200 plus corporates. Okay, and 400 plus sessions across 14 plus countries I have delivered. And I can say in this last 21 years, the journey was quite fruitful, and I'm working in the capacity of the full stack. And the microservice is one of my core service and the core technology where I'm working with. And with many of the corporates in the past, I have worked, okay, especially for helping them to fix their architecture related issues and how the microservices can replace the traditional monolithic application. This I have delivered it many times. So it's really great to see you all. So this is a 1 hour of quite insightful webinar where I would like to give you the idea behind how the monolithic will move to the microservices and what exactly we do in order to perform this operations. Yeah. So let me share my screen to tell you how those things are gonna work. Okay. I'm sure like my screen is visible to all of you. So let's get started and discuss about the microservice architecture and the idea about it. Well, first and most important thing I would like to tell you about this microservices, like here we're gonna tell you about the journey from monolithic to the microservice and what are the important patterns are used irrespective to any language, okay, or any platform you use it. So let's get started with an idea of what exactly the monolithic application is all about. I'm sure that all of you, those who are here for attending this webinar, you all come from the diversified background. Like many of you may be from Java, few of them may be from PHP, some of them will be from Python and Java, Spring Boot, or different domain. The problem is common across all the development industry. And what exactly the problem is? The problem is like the old school applications are still very unproductive, tightly coupled, and they are used widely in the industry. So if I can give you a very simple example about this, as you can see right in front of you, there is a online shopping portal where we have got product account payment login and order management. And the moment the multiple layers, as you know it very well, irrespective to any technology background, our application have a got three-tier architecture, correct? We have a call front-end layer, we have a call business tier, we have a call database tier, multiple layers we have it. And this three-tier architecture, after some time, we again divide into multiple furthermore layers, which you can talk about called multi-layer architecture. And in this multi-layer architecture, every layer designed to perform and to fix the specific issues. Okay, so here if you can see, we have got a business layer, we have got multiple modules are used together. And tomorrow, in case if I try to deploy my application, okay, so there are some advantages you get it in a monolithic because everything I cannot say that monolithic is always bad it sometimes serves the specific purposes too. So I've given some points here. Like as you can see, it is easy to develop, simple testing, and the quick deployment. So they are the some pros of monolithic applications. Okay, as we also know that today in a current generation, your user interface comes with a different layer, your backend comes with a different layer, and the database has altogether is a different picture altogether. When you would like to add everything, then it will be difficult for you to further break down. So how this microservice will help you, this I will discuss it, but these are the quick benefits which I can give it to you. And also you can scale up, okay, by keeping a multiple copy. Okay, it is less technical, but it is good for the small scale application. So if you're developing an application for the industry or for the company where we have around 40 to 50 employees, okay, or perhaps 100 employees, and you're developing some applications where complexity, you do not want it, but you want application which are very less upgrade. Okay, so not frequently upgrade, less monitoring is required. In such cases, the monolithic gonna be a quite fit for that. Okay, so when the company grows, as you know it very well, so the application also grows in that way. So you also need to understand that when the company grows, the complexity also grows along with this. So how we going to manage that? As you can see, the same application, if I can take same e-commerce based application, now the number of users are increasing, correct? Like as you can see here, uh, you have received the request from the mobiles, correct? And you also receive the request from the desktop based applications, like in you talk about um, mobiles, you talk about desktop, you talk about large desktop, and so-called web services. So different type of users are trying to access your applications and the different models altogether. So that's where exactly the challenges comes with. And what exactly the challenges? The biggest challenge is basically redeployment. Because if one part of the application changes, the whole application needs to be get redeployed over the period of time. Correct? And single point of failure is again a biggest issue. Single point of failure in the talking about, like if one particular portion fails, the entire application has to get recompiled, redeployed. Okay, so you cannot afford to lose the control on the entire application. Correct? Because of one particular portion fails. So you want to maintain in such a way, if one part fails, the others are continue to work. Correct? And you want the continuous deployment, because I'm sure that you people are aware about the DevOps. So you also want to make sure that your application continue to deliver the new features without having any issues. Correct? And in case of any bug fixing, you can easily do so. But in monolithic application, these are the biggest challenge, because as I said before, earlier applications, you really can't control, because if they are frequently upgrading, okay, frequently changing, and frequently you are adding some new areas into it and fixing the bug and talking to the third party applications incompatibility, it's going to be a great difficulties. And these are the so-called challenges with the monolithic application. Again, I'm repeating my word, I'm not using any technology set. You may stick to any other language irrespective to Java, Python, or .NET. The problem for the monolithic application remains there. So I'm not going to talk about which language you use it. I'm talking about a generic and very generic terms so that you can easily relate between monolithic and a microservice. Okay, again, there are few challenges like in high dependencies, and new team need to understand this each and every application. You really can't divide the work, correct? Because everybody knows everything. So when any specialization come, you really can't differentiate the team because everybody knows everything. So if one thing fails, you really do not know to which one do you pick to fix that, correct? So that is where the problems are, as I discussed earlier also, single point of failure and incompatibility with the new technologies. So the challenges continues. Okay, I told you high coupling reliability is again an issue. Continuous deployment is a difficult. So here is a question. What is a solution? So friends, here is a solution, so-called microservice. Okay, now What exactly the role of microservice? I would like to give you a very simple example without getting into the complexity. Imagine a use case, e-commerce based application, okay, where we have got multiple modules available. You talk about orders, you talk about payments, okay, you talk about product, you talk about deal of the day, okay, you talk about card application. Earlier, they were all deployed as a single unit. And due to what, if you want to upgrade any of the module, this entire application has to rebundle and redeploy. Okay. Here in microservice, what happens? The word itself is called microservice. That means you are dividing your applications into the smaller portions. Okay. Rather than sharing the same database, like what you used to do earlier in a traditional monolithic application where single database used to handle every single type of module. Here, the database is equally divided among all different type of modules. Clear? Due to what? If any service fail, okay, and that is one more advantage I would like to tell you now here is like your application also have a got dedicated server. Imagine if I'm using Apache Tomcat server where my product is deployed, and if that server fails, what would happen? The entire application collapse. Here, what is going to happen? Every single application is going to be deployed on a dedicated server. Okay, and every application will have a dedicated database, and you are connecting to all those applications through the gateway. So what would happen if one service goes down, or suppose if another service goes into the upgrades, so the other services without any impact will continue to work, correct? And that's something which really makes your microservice unique from the monolithic, because you have divided the every single module as a dedicated service that is called microservice, correct? So every service has got its own dedicated database. Correct. So there is no point of failing one database and collapsing the entire application or goes to the server. So here every application is deployed to the dedicated server in the database. So the maintenance becomes more easier so that if any applications tomorrow, if you want to upgrade, okay, without any challenges, you can upgrade. Or if any case, if one service goes down, others will continue to engage and work. And that is the beauty of this microservice, which I have recently discussed with you. Okay. Now, so there are some positive effects of the microservices. As I said, whatever the challenges you have seen it before, as I discussed with all of you during the time of monolithic, these all comes as a pros in the form of microservices. Like, as I said earlier, reusability, correct? Agility, you talk about self-organized. And the best part, I will tell you one more important thing is many people have come to me, they say, monolithic application can also scale. What you can do, you can add the more RAM. Okay, you can add more resources. But the question is like now, you are trying to scale your application vertically, not horizontally. You also know that maximum capacity beyond that, you really cannot add it. Like imagine you have a got laptop. Okay, your laptop can support maximum to maximum 24 GB. Okay, it cannot support beyond that. So even if you are currently purchasing 8 GB of laptop, but tomorrow based on your usage, you keep on increasing your RAM, but after 24 GB, it says that's it. We cannot extend beyond this. So that is the limitations, correct? Horizontal scalability is somewhere where the microservice steps in, correct? And imagine if you have an application which is a mediocre application, which is not very high, which is not very low. If you add some resources to your service, especially in a monolithic, and those resources going to be shared across multiple services or across different modules, out of which some modules may not require that much of resource, but few modules require that. I just give a very simple example to all of you. Imagine you go to Myntra or Amazon during the sale time. How many of you practically tell me you go and really purchase the items even during the high peak sale time? Out of 100 might be 30. That means despite giving the heavy discount, your number of products goes to the you can see the payment gateway, that ratio is only 30%. But many people go and visit your website. That means where you feel the maximum load is. The maximum load is on showing the list of product, okay, showing the list of items, showing the description, okay, but load is very less where on your payment gateway side. So where you think if you add a 40 GB of RAM, but you see the RAM is not effectively utilized by your payment gateway, but the RAM is less utilized by your payment gateway and most on where? On your front end application. That means the resources are not correctly utilized. And what tomorrow if the sale goes down, they say the sales days are over, now my application will remain to the neutral. So that resource which you have allocated, what you will do with that in a non-sales time? This is where again the another challenge, where the microservice wins the race. They say, I can distribute the resources only on towards where they actually needed it. So I can scale up, scale down according to my services rather than putting it everything under the one service and ineffectively utilize this. So I'm sure that you understand that is another benefit of using what the microservice, where you scale your services according to the need rather than utilizing it everything what you really want it. Okay, so I hope you understand about why it is a necessity of shifting our focus towards monolithic to the microservice. Because microservice have got other advantages. And what exactly the advantages? That is called it is a called cloud ready. What do you mean by cloud ready? Because your microservice will be deployed, okay, on the clouds. So you might need a containers like in Docker, you might need a containers like in what Kubernetes and all. So overall, when your application get deployed, you really do ready to get served by the cloud services by any service provider, but your services are cloud ready. But this case is not applicable on a monolithic. You can make your monolithic application cloud ready, but you really cannot guarantee that your applications are really cloud ready because some services need more resources, some resource services may require limited resources. And that's where the conditions are. Okay, microservices also comes with its own challenges like monitoring complexity, deployment complexity, increased resource consumption. That is there. But as you know, the industry is working hard towards streamlining the microservices. And in fact, it is more than a decade ever since the microservice has been introduced, and lot many tools have come to the market. Those who have brought some really serious services to the microservices due to what the microservices adoption rates are way higher compared to the earlier stages. Okay, and most of the companies either on the verge of migration or those who have already migrated. So the challenges will remain there. That is why the industry is continuously working to fix those challenges and keep your development more simple here. So as you can see, the fundamental changes of the monolithic application is a response to change, on-demand scaling, flexibility, and adopting new challenges better. And this is where the microservice is really winning the race. Now, microservice we all understand. Okay, some of you might have heard about a microservices. Some of you are already working in a microservice. Okay, but can I have a quick question from all of you? Give me the quick heads up. Okay, in a chat, those who are already working in a microservice, just give me the answer yes. Those who are really working on a microservice. At least I would like to know how many of you are really working in. Feel free to give me the heads up. Thanks, Vivek, for the quick updates. Anyone else? Those who have at least implemented once in a lifetime on microservices. Wow, great, Ashutosh. Good to hear. Others? That's perfectly fine. Okay, even if you are not, but make sure that you are ready. Because microservice is something which is a future, which we really can't ignore that. Okay, and that is why I would like to tell you knowing about the microservice is the one part, but following the best practices and the design pattern is another part. Many of users, in fact, when I'm in this industry, I work with, in fact, I'm working with all Fortune 500 companies. They ask a special session from our side. They say, Okay, participants know microservices, but they need to know the best breed of design pattern so that they can further distribute the application. So the microservice is not a, you can say, a API. Remember, unlike web services, which is a set of standard, microservice is the best breed of design patterns. It is a design paradigm, okay, where the multiple design patterns collab together to solve the complex issues. So you really cannot ignore that microservice is just like a generic term. Yes, it is a generic term, but every company uses the microservice as their own way. So important is you need to understand how these microservices are utilized and what are the important design patterns are used here. So let's get understand the microservice design pattern. Okay. So the question is like, is it mandatory to go through this? Answer is yes, it is. Now, if you see the complexities is small, okay, but over the period of time, the complexity is arising. Okay, so as you can see, here, according to the tree, it is growing, it is in the growth stage. According to the time, they also need lot of care, they also need lot of responsibility, they also need to be maintained properly. Likewise, when your application grows rapidly, okay, so it is essential for you to understand the design principle. So your design principles are divided into 8 important categories. As you can say, first is called independent and autonomous. Okay, all design patterns are independent. They are not enforcing, or they are not, I can say, putting a constraint for these design patterns or these languages you need to use it. Second, resilience and fault tolerance. That means your design patterns are resilient and fault tolerant. They're observable, they're observing the changes, they're discoverable, they can be identified easily. The services needs to be identified easily. Domain driven, as you know it very well, your focus should be always on where, on a domain driven. Decentralized, okay, so that you can decouple it and deutilize. High cohesion, single source of truth. So these are the basic principle of any design patterns must use it. If you're from uh, object-oriented background, I'm sure that many of you will be. So, there's a concept name called design principle and second called design patterns. So, if you talk about a design principle, so there's a principle called solid principle, SOLID. You might have heard about. In case if you're not, you can Google it, SOLID, solid principle. So, there are total 5 principles are available. Before you get into the design patterns, it is an important that you follow the design principle, which is a must have principle which every single application must have it. Okay, that is called design principles, correct? And second is called design patterns. So these are the design principle which every application, no matter which language you use it, they must have it. Out of 20 design patterns, you might use 10, you might use 2, you might use 5, depends on your requirement. But principles where you cannot ignore, because without those principles, design patterns would not make any sense. So I'm sure that you're understanding what I'm coming from. Okay, so independent and autonomous, as you say, so that is a benefit here because a small team size, it is good. Parallel development because many people can work together, clear contract, they know what they're going to do, and individual deployable. Okay. Resilient and fault tolerance means what? Your application must be resilient. It knows if one point of failure, how to recover it from there. Okay. So it avoid the cascading failure because if one fails, multiple will fail. So it avoids that. And that is the beauty of design principles to make sure that it happens. As you know it very well, it consider the failure as an event and analyze it properly and give you the proper answers, what it should do. Observables like monitoring system. Your application should know like which application is working properly or not. They should be completely into the health check systems, like they're checking the heartbeats, whether the application is working properly or not, maintaining the proper logs, correct, and taking care about the entire monitoring. Like the logs needs to be taken care so that if anything goes, well, or if something goes wrong, you need to know from where you need to go back and check. So traditional monitoring system is no longer valid here because we are talking about centralized monitoring system where application wide logs you're going to be storing it in one particular system. Okay. So discoverable. Your application must be registered under one phase so that if you want to locate where is my system, so it can be easily discoverable. Like you can talk about a Google. All websites are registered in a Google. So tomorrow if you search, Google should know, okay, this is a website, I need to know about it. Correct? So if you do not register your application to the Google, perhaps while search, your application would not come into this search part. So you have to make sure that your application is discoverable and one client can easily make it. Domain driven, focus on the business, focus on the core domain, what you're looking forward for. You are looking forward for product, you're looking forward for services, you're looking forward for the client services, that your focus must be very, very clear. So domains needs to be very, very carefully watched. Decentralized, as I told you before, every application should have what? Its own dedicated database. It should have its own dedicated server. So that your application is rather than centralized, it is decentralized. Every service is deployed in a dedicated server and a database. So that is a perfect choice. Many applications I have personally seen, they do not use a dedicated service. They say, okay, let application to be deployed, but they call it as a microservice. They may maybe call it as a microservice that is not an authentic microservice. As I said to you, if you do not bring design principles, design patterns would have no idea. Okay, so better you fix to or stick to those patterns, whichever I told, so that your applications remain always on a first priority. Okay, high cohesion. Okay, do one thing only. Single responsibility principles. If you remember, I told you some time back when I was, discussing with every one of you, saying that, hey, you should know that your application is doing only one job at a time. So solid principle, as I said. So solid principles means what? One responsibility at a time. Your application should not perform more than one job at a time. If it is, then distribute the responsibilities. Okay, so this is where the business cohesion is all about because it helps you for scalability and availability. Single source of truth. Okay, so as I told you, like your application should get the complete information from one source. There should not be multiple sources from where you are depending on. So you should have a single source of truth for where your application is centralized, taken care. Okay, so you should completely avoid dumping your data into the multiple locations. It should be completely organized and centralized. Okay, so these are basically the inputs we have given to you, which falls under where? Under the design principles. And now we're going to talk about what the design patterns, which are the key areas of your learning. Now, we need our applications to be highly available, scalable, resilient, and efficient, which anyways we know. Then what next? So they said design patterns are help or design patterns help the users to make sure that they come out from the traditional trap of the monolithic application and they maintain a proper solution where the application can offer a proper organized, you can say, the system where the complexity can turn to the simplicity. And this is where it comes with. Now, if I tell you about the design patterns, you see the design patterns are actually having these 5 patterns as you can read out right in front of you. So as you can see, we have got a total 7 types of patterns. Your patterns are actually not 4 to 5 design patterns. These actually patterns are divided into these 7 categories. Like in which type of categories you have it right now, on which your patterns are actually divided and distributed. Correct? So the first is decomposition, database, communication, integration, deployment, observability, and cross-cutting concern. So different type of design patterns are organized. Now you can see under the first called decomposition. Okay, here we have got very dedicated design patterns here. We talk about by business capabilities, by subdomain, strangler, and sidecar design pattern. Okay, decompose means what? You're dividing the job from the main application. Okay, I can give a very simple example to you. Like when you talk about dividing your functional requirement from the non-functional requirement. Okay, like you think about a situation. There is one application which is responsible to give you the registration, login, and the user details, user portfolio. But when you're trying to access any of those services, okay, logs are generated behind the scene to understand when the user logged in, what value he has given, when the user is trying to register, what are the details he has given, when the user details were okay, when the user details were fetched, so how much time it took. So these are the non-functional part which you would never make sure that the same application follows. Rather, you would like to keep another application or another supportive application which takes care about those jobs and you decompose it. And this is where the decomposition pattern comes with. A total 4 design patterns are available by business, by subdomain, strangler, and sidecar. Next, we have a called database patterns. Your microservices will certainly be a what using database for sure. Can you tell me that your application having no database? No, it is not. You will be having the database for sure. So there are total 5 design patterns are available. Database per service, which I anyways discussed with you. Shared database, as I discussed earlier, also many companies uses what shared database. They say we do not want to have a dedicated database. We want to have a shared database. That's fine. CQRS. Okay. So Saga and event sourcing. Okay. So there are the different type of design patterns are available. Database is specific. Okay, which are dividing the rules, okay, of query segregation responsibilities. So CQRS stand for what? Command query responsibility segregation. Like you want to make sure that one database is taking care about of what? Insert, update, and delete. One database. And you're using another database only for the iteration purpose. That means you're keeping two dedicated databases. Just imagine one database for insert, update, and delete, and another database only for the reading purpose. And these database records are getting in sync with each other. Sequence design pattern. Saga heavily used when you have a called distributed transaction. Event sourcing when you deal with the event-based programming. So different use cases. You think about an example of communication among services when microservices wants to communicate with each other. What design patterns they will be using? gRPC, GraphQL, HTTP, asynchronous, that is a different design pattern. You think about an integration pattern when you would like to integrate your application with a third party. You talk about API gateway, aggregator pattern, okay, client UI composition. Again, you have a call chain pattern, branch pattern. So you can go to any level, okay, in order to make sure that your applications are divided and organized. Okay, and we have a called deployment patterns. We talk about multiple service instance per host, single service, blue-green deployment. I'm sure that you might have heard about a blue-green deployment, canary deployment, serverless deployment. So the different categories are available in which you can choose your own way of how you want your applications to be deployed. So in a nutshell, I'm telling you, like knowing about what is a microservice, knowing about, okay, I've used few things in a microservice and my job is done. Answer is no. Design patterns is very, very essential for you to understand which kind of problem you can solve where. Okay, and you can see again in observability, we have a call 4 design patterns. In cross-cutting concern, we again have a got what? 3 design patterns. So you just imagine overall, there are almost more than 25 plus patterns standalone in microservices. In fact, I would say 30 plus design patterns are available standalone on microservices. And every different design pattern, not necessary that you need to learn or you have to implement all 30 patterns here. No, you can define, but design principles are very important. Remember, as I said, you might use few design patterns, you might not use. That is perfectly fine. But you cannot ignore the presence of design principles in your development. Design principles are called values which your microservice must have. Okay, so there are options called can have, that's called must have. Design patterns are can have, and design principles are must have, which you cannot ignore it. Okay, so you see about the different type of design patterns are available. Okay, so you think about microservices. Okay, how micro, how small. But before that, I would like to tell you about few more important things here so that you will understand this line here. Okay? This is called 12 factor principles. What I'm saying, everybody, 12 factor principles. Like every single principle, which is very, very important for every single developer to hold in. 12 factor principle. When you develop a microservice, whether these 12 factors are important or not, this I will tell you with the help of scalability. Now take a look about this idea here. What is the 12 factor principle? 12 factor principle is a pattern for SaaS, which is so-called software as a service. Correct or not? And microservices falls under which category? Software as a services. Correct or not? So if you want to develop or build cloud native scalable application architecture, so you need to have it those. Okay, 12 factor principle. There are a lot of details are there. I do not want to go much into the detail, but remember that the 12 principles are available. Code-based dependencies, config, backing services, build and run process, port binding, concurrency, disposability, dev and prod, and logs and admin process. If you have all those 12 flavors in your microservices, so it tells you how your application is a cloud ready. Take a look. Here we talk about modernization, different factors which are available. Zero factor. Zero factor falls under no cloud ready. Your microservice have a got benefits of auto scale and auto start. So there are zero factor. Zero factor means what? Your application complexities are more higher and operational benefits are very, very less. When you follow 1 to 4 factors, okay, when your application have a got minimum 1 to 4 factors, that means your applications can call it as a what? Call container ready. That means your application can be called as a what? Hey, my application is container ready, and these are the benefits you're going to get it. That means you can have readiness, liveness, health check, and logging. Okay, that means only after implementing 1 to 4, you can call it as a cloud ready. When you minimum implement 5 to 9 factor, you can call your application is called cloud compatible, where you have a call service discovery, externalized configurations. So if your application have got these services with you, that fall into which category? Call cloud compatible. And when your application have got minimum 10 to 12 or 15 factor principles, your call is called cloud native. So cloud native is very, very technical term. Cloud ready and cloud native, they're the two different options are available. Even if I have the application which is having 1 to 4 factor with us, I can call it as called cloud ready, but they are not cloud compatible. They are not cloud native. Cloud native means that you're using a lot of cloud related services. Okay, you talk about security, telemetry, you talk about API first, and many principles. So you can understand more and more factors you're trying to include in your project. Then only it is getting called as a called what? Call cloud native platform. So minimum to minimum, when we talk about called cloud native applications, so this is a very simple command I will tell you. They say the cloud native, please everybody watch out. Cloud native is an approach where it uses the cloud computing, like as you know it very well, the cloud computing features, and run a scalable application in more dynamic environments such as public and private and hybrid clouds. This is called cloud native applications. Okay, so you need to understand this point very well. Cloud native applications are the applications which can run, okay, in all three flavors: public network, private network, and hybrid clouds. So virtualization is something which is very, very essential. If you're using microservices, so you have to make sure that your application is virtualized, okay, deployed in any of the environments, whether you talk about a cloud, whether you talk about a, you can talk about local VM, or you can typically you can use called on-prem or the cloud environment. Anywhere you can basically utilize it. Okay, so you understand when you talk about a monolithic application, you're using the application and using all the resources which are shared. But here, if you just check, you are utilizing the containers and you can increase and decrease the services by increasing the size of the containers so that your resources are effectively utilized, because it is a shared resources, my dear friend, and you really cannot expect that one resource is using complete memory and one resources is lag of memory. It should not happen. You should make it very, very well. And this is where the option of what? The cloud native. Okay, so you have got multiple advantages, competitive advantages, flexibilities, business domains, many more. So when you talk about a cloud native application, so you get the benefits of DevOps, you talk about continuous delivery, which is so-called CD, you talk about microservices and containers. Only when your application have got these four flavors with you, you can call your application as a call what? Cloud native applications. And as I said before, that telling cloud native is what many people are confused, and many of them are really not aware about that there is a word called cloud native, and they really can't iterate this word. What do you mean by cloud native? So this is the current information and the current updates where you consider the cloud native application. So the DevOps, CD, microservices, and containers. Okay, so microservices, I already told you, I really do not want to divide this applications again and again. It is basically the service which takes care about the main business logic and take care about how the applications are distributed. Containers are responsible for deploying your applications, whatever you have developed in a microservice. So first you develop the microservice, then you go to where? To the containers to deploy your applications into the cloud efficiently. You talk about CD or CI/CD for continuation integration, continuation delivery, so that your applications remain consistent and takes care about all required new development, whatever is coming up, and deploy faster rather than waiting for the longer term. And the DevOps, as you know it very well, it is the plan of the delivery phase where the development and operations team works together, but it is only possible when the teams like in operations and the development team works together to offer that. Let me tell you guys, very, very simple. Like microservices, you know, have a got no limit. But when you talk about the implementation wise, so it is a cost effective, it is taking the benefits of cloud, it is using the storage, it is reliable, it is accessible. And these are what the main advantages of cloud native application. So it is taking the complete microservices to the next level by offering all the required ingredients. Remember everybody, microservice if you want to run, okay, so certainly you can approach to Suruchi and the other team members, those who are expert on their own domains. Okay, so you can certainly request in case if you want a dedicated session on the microservice because that is a huge topic. But design patterns are something which I've given you in a small insight. Like knowing about microservice is not important unless we know the design patterns properly. So we have a dedicated trainings on the design patterns where we spend 2 to 3 days together, take a small application, use all the microservices design pattern to solve the complex problem to show you how you can strengthen your roots towards your microservice because that is an endless journey. And since the new developments are coming up, we make sure that we give you the solid understanding of how these tools and terms are used. Okay, so I hope your understanding is improved towards the microservice. If you have any questions, I would love to handle all those. I know that out of curiosity, a lot of questions are there in your mind, but any questions, if you have it popping up in your mind, I would love to answer all those. But understand one thing, friends, microservice design pattern is not a destination, it is a journey, and that is an endless journey. Okay, you keep learning because the new tools are keep on innovating, so you have to learn the things accordingly. Yes, any questions from anyone which I can answer it? Yes, very much, Rajni. Microservices are used in Android too, that is called micro front end. Remember, there's a tool name called micro front end. Okay, so there also you can utilize the same. So micro front end is a next generation tool which is used in a front end based applications also. Okay, to release the applications accordingly. So the question is, yes, we can use it. Yes, we can use it. Yes, everybody, do not hesitate to ask if you have any questions. I would love to answer whatever you have it in your mind.
So we have another 10 minutes. So if in case if you have any queries, you can just post it.
No, Rajni, we have to use a proper framework. Okay, so we have to use the proper framework. The API remains standalone cannot really help you out because every application have got its own. Okay, so microservice is also provided for the microservices for the ASP.NET also. Okay, so you have to basically migrate it because ASP.NET is no longer valid nowadays. Pankaj, I'm sure that you are understanding this point. ASP.NET is no longer used because it is outdated technology. So slowly we have to migrate it because somewhere front end, back end, and again dividing it, again fixing it. So it is an important. So ASP.NET is a old technologies. I do not consider it in the form of microservice. I would call it as a call monolithic, which you need to. No, actually, I said Rajni, it is a micro front end. Front end, like I'm talking about, like as you said for Android. Okay, Android has the capabilities of dividing your application to a smaller portion. Okay, and also without using any framework, micro front end. Okay, I'm talking about. So you can use it standalone applications too to convert it. See, it is a practice I'm telling you. Okay, so it is up to you now how far you can go by taking this development and solve these issues. Any further questions?
Okay. I think we don't have any more questions left. So I'd like to thank you everyone for attending today's session on Introduction to Microservices and Code Design Patterns. I hope you found this session insightful, engaging, and valuable for your technical growth. Okay, a big thank you to Mr. Amarjit for delivering this session for us. And we look forward to seeing you all in the more sessions, upcoming sessions. And wish you all the very best. And thank you, everybody, for attending to this today's session. So thank you. Good day.
Very much.
Thank you, Mr.
Agree.
Amarjit.
Thank you.